Good day, students. Welcome to math.serve.com. In this clip, we're going to be going over problems 16 to 20 of the Algebra 1 Common Core August 2015 New York Regents exam. All right, let's take a look at problem number 16. It reads, which graph represents f of x? F of x is a piecewise function where you have the absolute value of x when x is less than 1 and the square root of x when x is greater than or equal to 1. Now, if you want to do this manually, you just need to remember what your absolute value and radical function parent functions look like. Okay, let's sketch those real quick. So this is a real quick recall. Now, the absolute value function, it looks like a v. Okay, so you have an absolute value function. It looks something like this. You have y equals x to the left and y equals y equals x to the right and then y equals negative x to the left. All right, so you have a v function like that for the absolute value function. Now, what does a radical function look like? So this is y equals absolute value of x. The radical function just curves to the right, starting from 0. So it looks something like this. Let's put this in blue. Like that. Okay? Now what's going to happen is that we're going to have a break on this value right here. To the right of the functions, you have the boundary points. So you see they are all happening around the value 1. So what does that mean? It means to the left and to the right, you have different functions. So let me illustrate with a number line. If you have a number line and you have 1 at the center, okay, when you are anything less than 1 to the left of 1, you're going to be looking at the absolute value function, okay? And then when you're anything to the right of 1, guess what? You're going to be looking at the radical function. Okay, so which of these graphs illustrates that switch? So to the left, all the way to this point right here, to the left of 1, we're going to have a v-like function. So let's look at the options. Which one looks like an absolute value v function to the left of x equals 1? To do that, I'm going to draw my boundary values, partitions on all the functions so you can see them. So that's 1, that's 1, that's 1 right there, and that's 1. Okay, so we're looking to the left of that partition I just drew. In each case, you can see that for the first one, option 1, that's a v, that's good. This is a v, that's good. This is not a v, this is a quadratic function as a parabola, so that's bad. And this is also a quadratic formula, which is a parabola, that's bad. Now let's look at the right side. Which one looks like a radical function? Okay, radical function goes towards the right. Okay, it doesn't curve upwards. The radical function curves downwards. So out of these two, which one looks like a radical function? We can clearly see that option 2 curves kind of like, it looks as though it's curving downwards, so this is our correct answer. This right here could be a quadratic function, or it could be a linear function, so that's no good. Our answer is option number 2. Now let me show you how to do this with a calculator. So you can graph both functions with your calculator, and then you can determine which the correct one is, or you can even graph the piecewise defined function directly in your calculator. Okay, so you just press the Y button, and let's just graph the two functions first. So absolute value, you go second function, catalog A. ABS means absolute value of x. Enter. And then the second one is the radical function, square root of x. Enter. All right, let's graph them. So that v is your absolute value function, and to the right is your radical function. Okay, so let's go ahead and input some boundary values so that we restrict the graphs to different domains. The absolute value is active when x is less than 1. So I go to my catalog, second function 0. If I go to my catalog, I need to look for the less than inequality symbol. So where is it? Go up. There you have it. So the syntax for entering absolute value functions, or piecewise defined functions, are as follows. The first function, you enter it, and then parenthesis the interval, so x less than 1. Enter. The second function, you enter it, and then what next? Parenthesis the interval also. So here x is greater than or equal to 1. So where can we find the greater than symbol? Go to your catalog. Everything is in the catalog. So second function 0 takes us to catalog. We're going to scroll up for the inequality symbol. You're looking for greater than or equal to. There you have it. Greater than or equal to 1. Close that. Enter. And then graph. There goes the absolute value stops. And there goes your radical function down. Okay, it doesn't look perfect at the partition where the switch happens because of the nature of the programming software we have here, but it's good enough to help us see what the answer is. So we can clearly see that our answer is option number 2. You have the absolute value function here, and then the radical function happening to the right of x equals positive 1. All right, let's take a look at problem number 17. It says if f of x equals x squared minus 2x minus 8 and g of x equals 1/4 x minus 1, for which values of x is f of x equal g of x? Now this is another calculator problem. Well, how do we know? Well, if you look at the options, we have decimal values there, which is easier to determine using a calculator. Okay, so let me show you how to do that. If you're given two functions and you're looking for when they're equal, what you do is you're going to graph the two functions and look for something after that. Okay, so let's enter the first function f, x, press the y button, x to the second power minus 2x minus 8. And then the second function is 1/4 x minus 1. Enter. Okay, now graph the two functions. There goes the quadratic, and there goes the linear function. Okay, now we're looking for x values. Okay, what are we looking for here? If you have two graphs and you're looking for when they're equal, you're looking for the intersection. Okay, so if you look at this graph, you see this intersection here. Let me make it a little bit bigger. The intersection to the right, what do you think that value is? This window is not cooperating. Let's see. Okay, there you have it. Okay, so this value here, this x value, what x value is that? Well, we can trace, press trace, and then push, just go to the right. That looks like 1, 2, 3, 4. Let's try 4. 4, enter. Perfect. That is an answer. So x equals 4 is an answer. We can take out anyone that doesn't have 4 in it. It can be 1 and it cannot be 3. So look at the next x value. It's somewhere to the left of y. So what do you think that is? Could it be 0? Absolutely not. It's negative 1 point something. So we can see that our answer is option number 2, because that's the only one that has a negative and a positive with the value of 4 included. So this is not an answer. All right. Now let me find the value of that intersection for you, just to satisfy your curiosity and to also show you the procedure for computing intersections using a calculator. So the process is as follows. You press second function trace, which gives you access to the calculate menu. You scroll down to option number 5, intersection. There are two functions here. It asks for the first. The quadratic is highlighted, press enter. Second function, the linear function, look at this right here. It tells you is that the second function. Press enter, and it says guess. Guess basically requires you to situate the cursor at a point that's close to the intersection point, and then the computer can determine what that value is. So just move the cursor to any point in the neighborhood of the intersection you desire to compute, and press enter, and it does the rest for you. Negative 1.75. Perfect. So we see that our intersections are x values negative 1.75, and the other one is 4. Answer number 2. All right, let's take a look at number 18. It says Alicia has invented a new app for smartphones that two companies are interested in purchasing for a 2-year contract. Company A is offering her $10,000 for the first month and will increase the amounts each month by $5,000. Company B is offering $500 for the first month and will double your payment each month from the previous month. Monthly payments are made at the end of each month. For which monthly payment will Company B's payment first exceed Company A's payment? So for this one, we'll just simply create a table and manually compute how their payments accumulate over the 2-year period. Okay, we're going to stop at exactly the point in time where the payment for B exceeds that of A. Okay, all right, so I'm going to split it into 3 columns. So let's see here. Column A will be for A. The first column will be for A. The second column and the second one will be for B. And then this is going to be number of months. All right. So after the first month, what happens? After the first month, what happens? So A starts with $10,000 for a month. So we have $10,000 for the first month. It says Company A is $10,000 for the first month and will increase the amount by $5,000 every month. Okay, so we have $10,000 for the first month for Company A, and then for Company B, $500 for the first month. Okay, now what happens? All right, now for the second month, Company A is going to increase by 5,000. So you keep adding 5,000. Okay, so for month 2, we're going to add 5,000. So let's go ahead and do that. So plus 5,000. That gives you month 2. Month 2 is going to be 15,000 for Company A. And then how about Company B? You double the previous month. So you double 500, 2 times 500 the previous month, and that gives you what? 1,000. So Company A is still ahead. We keep on going. For the third month, you add 500 to Company A. 5,000. And that gives you 20,000. And then for Company B, you double the previous month. So 2 times 1,000. That gives you 2,000. Okay, we see that Company A is still ahead. Let's just put some lines there. All right, now we're going to advance to month number 4. To do that, we add another 5,000 for A, and we have 25,000. After 4 months for Company A, and then for Company B, what do? We double. 2 times 2,000, and that gives us 4,000. Company A is still ahead, way ahead of Company B. We gotta keep going, okay? Now, one thing you want to notice is that company A's growth is linear and that of company B is exponential. So eventually, company B is going to catch up, okay? So for fifth month, you add 5,000. Month number 5, that gives you 30,000. And then for company B, you double the previous month, which is 4,000. And that gives you what? 8,000. All right, keep on going. We gotta keep up with this. You're gonna see the growth have to take off in a second. Sixth month. For the sixth month, you add another 5,000 for company A, which is 35,000. And then for company B, we double the previous month, 2 times 8,000, which is 16,000. All right, keep on going. We're waiting for the first month where company B's payment exceeds that of company A, okay? All right, and if you look at the options here, it starts from 6. So the answer should be coming up relatively soon. All right, so for the 7th month for company A, we add another 5,000, which gives us 40,000. For company B, we double the previous month, which is 16,000. And that gives us, what does that give us? It gives us 32,000. Wow, look at that. Have a nice little jump there. So 32,000 is getting close. There was a big gap before. Now the gap seems to be shrinking. This is after month 7. Now let's see what happens in month 8. It looks like it might actually cross it right now because it's so close. So this is month 7. And then month 8. For month 8, what do we do? Add 5,000. For company A, this additive relationship, this is a linear growth. So it's 45,000. And then check out what happens with company B. You double the previous month. And look at that, 64,000. Company B has exceeded company A. And guess what's going to happen? That gap is only going to get bigger in subsequent months. So we can clearly see that the second offer is much better than the first one. All right? Because the period of time, we're looking at 2 years, which is 24 months, and it's just the 8th month, not even the first year, and company B's payment has exceeded that of company A. So question is, but for which monthly payment will company B's payment first exceed company A? That is clearly 8th month's payment. Number 3 is your answer here. All right, let's take a look at problem number 19. It says the 2 sets of data below represents the number of runs scored by 2 different youth baseball teams over the course of a season. So we have Team A's scores right here, Team B's scores. And the question is, which set of statements about the mean and standard deviation is true? So basically, we have to find the mean and the standard deviation of these 2 sets of data. You can do that by hand, but since we can use a calculator, we might as well take full advantage of that. Now, what I'm going to do is I'm going to be computing the mean and standard deviation using the TI-83 calculator. First thing we're going to do is enter these 2 data sets as lists in the calculator, okay? So what I'm going to do is I'm going to go second function stats. Actually, just press stats, and it says edit. You press that, enter, and then you have your list 1 and list 2. What you do to enter the list is you highlight the first cell of the column that you desire, and you just enter the numbers. So I have them entered already. You just press 4, enter 8, enter 5, and it just goes down. Go to your right for the second list, 5, 9, 11, 4, 6, 11, 2, 7. Just enter all the numbers in your list, okay? All right, good. Now let's check to see what we have. So second function 1 calls up list 1, press enter. They have list 1. Second function 2 calls up list 2, press enter. You have list 2. You can scroll to the right, of course, to verify that the entries are correct. Now we're going to start computing the mean and the standard deviation. Let's start with A. So let's go to catalog. I'm looking for mean. Remember, you can find all the operators on the catalog. Second function 0. So mean M. Where's M? M is right there. Let's see. Oh, there you go. Scroll down to mean. Enter. We're looking for the mean of what? A, which is list 1. So second function 1 calls up list 1. Press enter. So the mean of A is 6. Now we want to look for the standard deviation. Where do you think we can find the standard deviation function? Catalog, right? Second function catalog. We're going to S. Let's see, S for standard deviation. Scroll down. Standard deviation, where are you? Let's hope it's here. Oh, there you go. Scroll up. STDDEV. Enter. Standard deviation of what? A. So second function L1. Close that. Enter. And we have the standard deviation. So let's go ahead and write it down. So mean for A is 6. And then standard deviation for A is approximately 3.3806. We're going to do the same for B, and then we're going to compare them. Okay, we're going to see which one is bigger, because in this problem we're not just looking for the standard deviation and mean, we're actually doing some comparison with the results that we get. Okay, all right, so let's see how we can do this faster. We already have mean called up, so we press second function entry to call up standard deviation. Press it again, called up mean. Now guess what? I'm just going to change L1 to L2 by highlighting L1 and pressing second function 2. See that? Enter. 6.875. Mean of B is greater than mean of A. Now let's do standard deviation. I don't want to go to the catalog and scroll. That takes too long. So what can I do? Second function entry calls back the previous entry. Second function enter calls up the entry before the previous. I change L1 into what? Into L2. Okay, L2, enter, bam, there goes your standard deviation for B. Let's go ahead and write these results down. So this is for B. It's approximately, let's see, here's my calculator. So the mean of B is 6.875, and then a standard deviation is 3.2. Okay, 3.27. Okay, now let's compare them. So mean of A is, let's look at the options here. Mean of A is less than mean of B, right? So take away the greater than, take away the greater than. All right, so this, wait a minute. Yeah, mean of A is less than mean of B, good. Standard deviation of A is greater than standard deviation of B. Bam, there you go. All right, it's not less, so take that out. Answer is option number 1. All right, let's take a look at number 20. It says, if Lila completes the square for f of x equals x squared minus 12x plus 7, in order to find the minimum, she must first write f of x in the general form, f of x equals x minus a squared plus b. What is the value of a for f of x? So let's go ahead and complete the square here. We have f of x equals x squared minus 12x plus 7. Now, we're first of all going to group the first two together as an incomplete square that we are going to be completing the square momentarily, okay? So to complete the square, we're going to be adding a term that makes this grouped term a perfect square trinomial. Okay, so we're gonna try and figure out that term. Now, since we're adding a term to the right side of the equation to preserve equality, we must subtract that value 2. All right, so what term completes the square is simply b over 2 square. That's how you complete the square. In this problem, a is 1, b is negative 12, c is the term that completes the square, which we're about to determine. All right, so b is what? Negative 12. What do we do next? To complete the square, we divide by 2, which is negative 6. And then we do what? We square it. b over 2 square is negative 6 square. When you square negative 6, what do you get? Plus or minus 36. You get positive 36. Be careful, because anytime you square a negative, you get what? Positive. All right? Remember, minus times minus is plus. So let's insert that 36 here and here also. Now let's complete the square. That should tell us the value of a that we desire to find. So how do we factor this? You can use your X game, factoring by grouping, or the box method. But since this is a perfect square trinomial, there is a pattern or a trick we can exploit here, which is by rooting the first and the last and bringing down the middle sign. You can always do this for perfect square trinomials. So here you're going to have x minus 6 quantity square. Positive 7 minus 36 is negative 29. So f of x equals that value right there. Now we're looking for a. To find out what a is, I'm just going to copy down this formula down here. So the formula is f of x equals quantity x minus a square plus b. So we see that a is positive 6 and b is negative 29. Okay, if the signs match, just take the numbers. If the signs do not match, you take the opposite. So our answer is option number 1. Thanks so much for taking the time to watch this presentation. We appreciate it. If you found this tutorial beneficial to you, do give us a thumbs up. We appreciate the positive feedback. Do not forget to subscribe for updates to the remainder of this review installment. And if you have any questions or need any support getting ready for the Regents exam, just place your questions in the comment section below, and we'll be glad to address it as soon as possible. More clips can be found on math.serve.com. Thanks again for watching, and have a wonderful day.